In this episode, we're going to focus on sprites and layers. And a sprite in this case is something that moves over the screen and over the background. So we're going to draw the background in one layer and I'm going to draw the sprite in another layer. So I'm going to show you here what our goal is in this episode. We're going to draw a little Mario here that can move over the screen, and then it's just going to continue out here. The reason we create this trail here, it's going to become obvious throughout the episode, and it's fine. Like, we are redrawing the background, but we don't draw anything up here because we don't draw anything that doesn't need to be drawn. So this is a side effect that won't be there in the final product. Okay, so let's get started and go into our editor. And the first thing I'm going to do is some housekeeping, because this code has a little problem that I want to fix first. And the problem is that load image and load level are loaded in sequence. Let me show you here what I mean. First, we load image. So I can write a console log here that says image loaded. And we log the image. Then another log message here that says level loaded. Level loaded. And we can just output the level here. So if we go back here to our code in progress, see here at image loaded and level loaded, and it was pretty much instantaneous. And the reason is because we serve this from a web server locally, so it's really fast. But that's not always the case, so we should be able to optimize this a little bit. In order to make the problem more apparent, I'm going to add an artificial delay here. So we're going to open up our loaders file here, and when the image is loaded, we're going to delay with 2 seconds. So I'm going to type setTimeout. And setTimeout is a call to the JavaScript event loop that queues a call to a function x milliseconds. So we're going to call resolve in 2000 milliseconds, and we're going to call it with argument image. So now we can comment this out, and now the image should take 2 seconds to load. So refresh and see 1, 2, and there's the image and then the level. This took about 2 seconds in total, but if we add another delay to the load level function, we will see that the delays accumulate. So I'm going to add here to the promise chain. Then we get the JSON object out here, and we're going to return a new promise with a delay in. This delay will be 3 seconds, so 3000 milliseconds. And the argument is the JSON. Let's run this and see what happens. 1, 2, the image came in. 4, 5, the level came in. This is very suboptimal. The way to mitigate this is to load these two in parallel. Let's go back to our main function, and we're going to refactor this a little bit. First, I'm going to split out this first part of the chain into its own function. So I'm going to cut this out here. Create a function called load background sprites. Function load background sprites. Did I actually type that right? Yeah, I did. And let's paste it in. There we go. And in the end of this promise chain, we're gonna return the sprites instance. Return sprites. And from this function, we need to return the whole promise chain. Now we can use our utility function of the promise class that parallelize two promises. You do that by running the method Promise.all, give it an array of promises, and then it will resolve with an array of the results. So if we put in, for example, promise A here, promise A, and promise B, then we will get out result A and result B here in a function. So let's replace this here. So first we want to load the background sprites. So we put this here. And then we want to load the level. So I put that here. And now we'll get this out here. We will get out sprites. And we will get out the level. So that means that this thenable becomes obsolete. So we can just copy and paste the inner of the whole chain and remove these unused syntax blocks. And we save this and we go back to running and let's see what happens. 1, 2, 3. So now everything loaded in 3 seconds. That means that image and level was loaded in parallel. And we should always try to do this. If something can happen in parallel, it should happen in parallel. Let's clean up the things we added here for the diagnostics. Remove the console.log here. And then in the loaders, we want to reset this to original behavior. So I can just undo everything I did. And I save and I close. Now I'm gonna find a Mario sprite set here with the characters. So I'm typing in Super Mario 1 character sprite set here. Let's go to images. I think this looks good. I recognize it. It looks great. I visit this site. Pixel Central. Whoops, this was some tricky shit. Let's get rid of that site because that did some freaky things. This is strange though. I literally just... Let's remove set and see what happens. Okay, now we're on another site. Okay, let's do this. Let's try this as instead. And the characters. And we're gonna put this in our images folder. There we go. Characters.gif. I also want to open this file in Google Chrome so we can see. Look at it a little bit. So I want to find this sprite. This Mario guy here is what we need to find. Let's erase this. How do I do that? It's not like that, at least. Okay, this is this one. Perfect, there we go. So, back to our code. And I'm gonna create a new function here that is similar to load background sprites. Gonna copy this actually, paste it in. And it's gonna be called load Mario sprite. It's gonna be called just sprite. And we have characters.gif. And we want to define the idle Mario. Remove sky. And we're gonna estimate that we want something from place 16 to row 3. So now I'm just estimating apparently in 16 by 16 pixel increments where this guy is. So let's see if we were accurate. We were not. And I think one of the problems here is we forgot to draw this. So let's copy this function call into here. And call this Mario sprite. In the end, after drawing the background, we're gonna say Mario sprite.draw idle on context. And let's draw him at 64 and 64. There we go. So this is not right. We think we are one off at least. So let's up this to 17. And here we go. So what we can see here that the way Sprite Sheet class works now is that it's way too rough. We need to be able to specify exactly what pixels we want a sprite to be. We're gonna go back and refactor the Sprite Sheet class. Let's open it up here, spritesheet.js. The first thing I want to do is say that we want to give the width instead of taking it from the class properties. I'm gonna add width here and height here. And I'm gonna replace all the instances of this.width with the width. And I'm gonna replace all the instances of this.height with height from the arguments. Then here, we don't want to multiply this here at all. So just gonna remove the multiplicator. And let's see what happens now. So everything is just wrong. This is because this method is not compatible with the previous method. So we're gonna create a new method called define tile. Tile is gonna be the equivalent of draw tile is to draw. So we call this name, take an X and a Y. And it calls define with the proper arguments, which should be this.draw and no, this.define name and x times this dot width, I think, and y times this dot height, and then this dot width and this dot height. So I think this method, define tile, is now compatible with the previous define. And in order to prove this, we go back to our main and we update all the calls to define to be define tile. And great, we got the sky and the ground back. So what happened to Mario? He is nowhere to be found. And one of the problems is that the define method now takes a width and a height argument. So now basically we're creating a subset of 0. So let's add 16 and 16 here and see what we get. And we get something that's not right, but we have the freedom to move exactly where we want. And since I prepared this episode, I happen to know exactly what this part of the image is. So let's go back in the code and type that in. And I have here in my notes is 276 and 44. So little Mario is at that location. And let's see if that is correct. And there he is. So that's perfect. That's our Mario tile. So as part of our never-ending quest of always keeping our code nice, clean, and maintainable, we're gonna put these loader functions for sprites into a module. So I'm cutting these out, creating a new file, I'm pasting them in, and I'm saving this as Sprites.js. And in order to make these importable, we need to export them. So say export function, and export function again. We save again. Then we go back to main, and we import them just as we imported from loaders. We say import, what is it? Load Mario sprite and load background sprites from Sprites.js. And whenever we refactor, we should always test immediately. And we didn't fix anything, so good. Let's see what we did wrong. Yeah, we're missing load image. We need to move load image into the Sprites module. So let's copy this line, remove the unused load image here, save it, go to the Sprites module, and we just paste back this thing here, and we can remove the unused load level. Save again, and let's try it. Nope, sprite sheet is not defined. Oh, this is really cool. Of course, we need that too, because we don't use this in the main anymore. That's part of our loaders and sprites now. There we go. And that's pretty nice. Now we have really cleaned up the main file. Kind of the core of a project. Like, you can write everything the first time dirty, but constantly be able to clean up, minimize, make it easy to see what you're doing. So now we're gonna look at how to move Mario around the screen. The first thing I'm gonna do is add a little position object here that's called const pos, and it's just an object with an x value, it's gonna be 64, and a y value that is also 64. Oh, now we can use this position object here to draw from it position.x and position.y. So let's see if it works. It does. Now we want to do this multiple times and want to change the position while we do it. So I'm going to create a little function here called update. Function update. And we draw Mario at the position object's position in it. And after we draw, we're going to change the position. So pos.x plus equals 2. And let's change the y position as well. And in the end of this function, we're going to call ourselves again using request animation frame. Request animation frame update. And request animation frame is something that the browser has built in, and it takes a function and it will call this function the next time the browser is ready to draw something on the screen. This makes animations more accurate, and this is what you should use when you draw things on the screen. It also takes into account the user's refresh rate on the screen and stuff like that. Before this is gonna start, we need to run update at least once first. So let's see what happens now. There we go. That's Mario coming off the screen. And he's leaving a trail after him. And this is not good. Like, we're just painting over the background. And we can't do that. So we need to come up with some idea how to fix this. One way we can do it is to just copy this method down here and always redraw the background first. This should solve it. There we go. The problem with this is that the background never changes, and we should be more accurate than that. So we're gonna draw the background a buffer and then gonna draw from the buffer. So let's move this back up, and we're gonna create our buffer. This is similar to what exists in the sprite sheet class. Const background buffer equals document.create element canvas. And in our case, the background buffer will be the size of a Nintendo screen. So background buffer.width equals 256. Background buffer.height equals 240. Then we want to draw on the background buffer instead of directly on the context. So we say background buffer dot get context 2D. And then we can draw the background buffer on the context. Context.draw image background buffer and draw it at 0, 0. So we have the same effect, but we don't loop over all the tiles here while we draw. We just draw the tiles once on this buffer and then we replace the background from the buffer on each time. Okay, so this is a little bit nasty. There's too much going on here. We need some cleanup right now. I'm gonna create a class that I call a compositor. The compositor's responsibility is just to draw all the layers in an order. So let's start writing our class here. That is class compositor. And it has a constructor. And the constructor instantiate a layer array. Then the compositor has a draw method. That's draw. It draws on a context that we're very used to now. And it loops over all the layers and draws the layers. This.layers, whoops, I put the keyword on the mousepad. This.layers.for each, and we get out each layer here. And then we send the context to the layer. So what is a layer exactly? The layer is a function that draws on a context. That's the only responsibility it has. So the function of the layer needs to contain all the information to draw itself. Such a function can be easily made using a higher order function. And the higher order function is a function that returns a function. Let me illustrate this by making a create background layer function. So we write here function create background layer, and we need the backgrounds and we need the sprites. Then here we initialize a new buffer and it's gonna be the same as background buffer here. Paste that in and we're gonna draw immediately. But we're not gonna loop over the level.backgrounds, we're just gonna use the background. So let's remove this level prefix here. So actually this is actually backgrounds with an S here. And then finally we return the function that draws. So we say return function draw background layer context. And in here we take this part of the update loop. We can clean up this function a little bit. For example, now we have it scoped, so we don't need to call it background buffer. We can just call it buffer. It will be obvious that it's the buffer of the background layer. And now we can just create a layer here. Const background layer equals create background layer. We take the level.backgrounds and we give it a sprites. Now we have a background layer here that we can draw, so we can give that to the compositor class. We instantiate that here. Const comp equals new compositor. Then we can say comp.layers.push background layer. And then in the update loop, we can say comp.draw on the context. Does this work now? It does. So now I think we have hugely improved how the layers are handled. We want to do the same for the sprite layer. So I'm going to create another higher order function here called create sprite layer. It will take a sprite, it will take a position, and it will return a function called draw sprite layer on the context. And it takes sprite.draw. We're gonna hard code in the name idle here for now. It draws it on the context and it draws it at position.x and position.y. This is the exact same draw call that we have down here. So now we can remove this, and up here after position we can create the sprite layer. Const sprite layer equals create sprite layer. We send in with a Mario sprite. We send in the position, and then we add it to the compositor. We save this and we try it out. There we go. Fantastic. Fantastic. So it's time to clean up a little bit. We obviously want to put the compositor in its own module. So I cut it out. Create a new file. I make sure we export it as default. Default. And I save this as compositor.js. We close this. And we import it at the top. Import compositor from compositor.js. And after refactor, we try it immediately. It works, fantastic. And now we want to decouple the create background layer to a layers module. So I cut this out, I save, create a new file. Paste this in, I export it, I save it as layers.js. Then we also have to paste in the draw background function into the layers. Where did it go? There it is. And we're only using this function inside the layers.js, so we don't need to export this. It's going to be private to the module. Then in main.js, we need to import it. So import create background layer from layers.js. And now we have it. We seem to have most of the things right. And let's try it and run it. Perfect. I'm so happy that went well. That's pretty much it for this episode. But before we leave, we want to clean up a little bit more. First of all, I want to rename this ambiguously named sprites variable into background sprites. Because otherwise that's a thing that's just due to bite us. And then last but not least, we want to create a Mario army. So here in the draw sprite layer, we want to have a for loop. For let I equals 0 to I is less than 20 and plus I. I'm going to draw a sprite and we're going to draw it on a position that is, plus I times 16. And hopefully now we get a ton of Marios. I'm also going to reset the position here to 0, 0. There we go. That's a sprites and layers episode.